Alrighty, all set.
All right, I see the live button. Okay, I'm Dan Beavers, and we're going to go over some QGIS activities today. This is mainly relating to after you have mapped uh, some ground areas and you want to put them after you've taken photographs, aerial photographs of something, and you want to put them in a map. Well, if you want to use QGIS, then I have a workflow to do that I'm going to show us. And okay, there I'm going to turn on my desktop, share my desktop, and select. Oh, let's see.
I find it easiest to do the one that's just we see what you see. I think it's the first selection. And then you can minimize the hangout.
All right, there's full screen, and yeah, all right, that's probably it. I see. Okay, now I can see you again.
Minimize me.
Okay, you can see the QGIS screen now?
Yep, got it.
All right. Okay, so the first step is to get a base layer in the map. And I have already put those into a folder, and it is mine called Superfund Seamless 1 foot. Can you read the text?
Yes.
Good. So I select it, and this is just like a directory structure here. Then I click on this Add Selected Layers, and voila, we have an underlying base layer that we're going to use to place the aerial photographs on. This base layer came from MARIS, M-A-R-I-S, and you have to Google that. And that's the Mississippi GIS repository. And what I did was I downloaded the most recent aerial photographs that were available there, and unfortunately it's a 1 foot resolution for this area, and the smallest area that I could download was the whole county. That took about 12 hours to download, and it's usable, but it slows down the just the workflow when you have the whole county in the background. So what you do?
I have a question. So are you
Sure.
are you about to say that you're going to clip it to just the area that you want?
Yes.
Okay. Never mind.
Okay, so you go to Raster and extraction clipper. And what you do is you select the layer, and we only have one layer on the layers panel over here at this point, so it's not, you don't have to make much of a selection here. And output file, you select some name. I suggest you put it in the same folder that you're going to be working out of. I'm not going to do that. I've already done this step, so I'm just going to illustrate what I have done already. And the file type, GeoTIFF is probably the easiest thing to do. There's a huge list of possible output formats, but GeoTIFF is probably the best choice. And let's see, I'll close that. And you should probably select extent. The no data value, I'll come back to that in a minute. You can leave that unchecked. and then load into Canvas when finished, and that will put it into this area over here. This area down here is the command that it will use to click the it's a GDAL program. Could somebody mute their microphone, please?
You should be all set now.
Okay. So this is a GDAL program, and if you click on the help, it will give you all sorts of information about the actual command, and you can go in here. If there's something weird you want to do, you can add that in here by just editing this text, and that's true for just about all of the translation commands and stuff that give you this area to you as an option. So I'm going to close that, and so well, no, I think I can do it. So I move it out of the way, and I go over here, and yeah, there we go, and do that, and answer the questions, which is I would do OK and put it into the output file. But I'm going to not do that since I've already done that. It's a pretty simple process. Anybody have any questions about that? Let's do it that way.
Could you talk more about the GDAL process of that command?
Yeah, GDAL is a whole bunch of utilities that are maintained external to QGIS, and I think you need to load those in separately, or they come as an option with QGIS. I forget, but it's a whole bunch of utilities for GIS things. Anybody else have a question, or did that not answer the question? Okay, none. Moving on. Okay, once we have our base layer, we right-click on the base layer, and we go look at the properties menu. And if you look under General, there's all sorts of things over here. Histogram. If you look at General, we have a coordinate reference system, and that's CRS is how that's abbreviated. And we need to remember that this is MAD 83 in Mississippi East, and it's in feet, US feet. That will be important in a little bit. So that's all we need to do is just look at that, what the actual coordinates is. That's a projection of the aerial photograph that relates the aerial photograph to a spot on the Earth and makes it fit a sphere and a projection. It's kind of, we don't really need to go into a lot of detail on that. I mean, you can look that up, but that's what that does. So the next thing you probably really should do is go over to the project up here in the left corner and select project properties, and the CRS, as I just remembered, select enable on the fly CRS translation. I'm not real sure exactly what that does, but I think it will translate other coordinate systems into the project coordinate system. And you'll see that if you click on anything up here, it will appear down here, but what we want is this one right here, MAD 83 Mississippi East. And that appears in the selected CRS. So this is the project coordinate reference system. Click OK. All right, now our project is the same as our base layer. So everything should be, you want to keep everything the same. Okay, now, all right, we have a bunch of photographs that we have collected from a balloon or a kite or something like that. and they're in this file right here under demo. And now how do I place those photographs onto this base layer? That's the where we're getting down to the nitty-gritty. So we go back over to Raster and Georeferencer, and again over to Georeferencer. That brings up the Georeferencer window, and we go click on the Open Raster. All right, now I have a bunch of rasters in here already. And let's see, I've already fooled with that one, so let's fool with this one to see what we do with that. That opens it in the Georeferencer, and the little yellow ribbon that came up there tells me that it doesn't stay up very long, but I know what it says. If we go click on the transformation settings, which is kind of like a yellow gear icon, we need to do a bunch of configuration items here. These are the parameters that are going to be used to translate the photograph into the coordinate reference system that our base layer is using. So the transformation type should be, for what we're doing here with aerial photographs, should be projective. You'll notice that there's several options. But projective appears to be the best option for what we're doing. And the resampling method, cubic, is the best for that. And this is from what I've read. I'm not an expert on this. This is just what I understand. These two options are best for what we're doing. The target SRS, and this is the source reference system, or I think that's what it stands for. And here we go again as to the, hard to read there, our reference system. We have NAD 83 Mississippi East. We want that to be the same as our base layer. So this is what it's going to project into that coordinate system. Compression, okay, output raster. That is the file that is going to be placed in the same directory that we're using, unless you want to place it someplace else, but I suggest you place it in the same directory system. And just, I have been finding that this is really convenient just to let it rename the output file. And it's a TIFF format, just so if you just take the defaults, it's going to put it into the same folder you're using, and name it something different. So let's save that. Compression, I'm not thinking that compression is important. Use 0 for transparency when needed. That is important to be checked, because you will have, if you don't check that, you'll have some, not a simple rectangle. You're going to end up with a parallelogram or another similar shape that will have black borders on it that are not transparent. So you want transparent borders around the image that you're going to place on the base image. So that's what we're doing here. 0 will be the indicator that it's transparent. Okay, target resolution, don't need to worry about. That will be the default. And then there's a couple of reports you can generate that will be PDF files, and they'll go into the same directory if you take the options, but I don't think they're important at this point. And then the last thing is the load in QGIS window. That'll put it on your map. So we select OK. And here we have the image we selected. And now we need to figure out where this image appears on our base layer. All right, well, I have fooled around with this enough, so I'm pretty familiar with it. When you open QGIS, it seems that the default is the squeeze and the finger instead of mouse movement icon. So if you select on the hand, then you can move this map around. And the response is a lot better because I've clipped out the rest of the county. Let's see, this area is right about there. And if I zoom in with my, no, it's right there. Zoom in with my mouse button. We can see that this rectangle right there is this rectangle right here. And these two, I guess, driveways, concrete walkways, whatever they are there. And we have several other things that we can see that we know where we're going to place this aerial photograph onto the base map. The base map I didn't mention was, I think it's 2 or 3 years old. I don't remember. It's not real old, but it's only 1 foot resolution, whereas our aerial photograph has a lot better resolution. And that is the real reason that we're doing all of this, is because we have a lot better resolution on the aerial photographs. So, okay, first thing we do, we have set up this, and we need to select a point on the aerial photograph that corresponds to the same point on the base map. And I'm not going to be real accurate with this because I, don't really want to spend the time on it that much. So I'm going to select this point right here, and that pops up this menu. And what you can do, if you know, we're not going to use this, but if you know the coordinates of the point that you just picked on this picture, then you can enter them here. But we don't, so we're going to click on From Map Canvas. So click on that, and that turns us into the icon at the bottom. And we're going to click on the base map right there. And that brings us back up, and see it's filled in the numbers for me. And doing OK. And we have 0.0. You notice at the bottom of the GCP table, we have ID is 0. Oh, by the way, I forgot. There's a setting that turns on the numbers, georeferencing, show IDs. If you go to the configure georeference, that's how you see the IDs. If you leave that off, it's confusing. But sometimes you might want to leave it off because it covers up something you need to see. But I found that you need to go check that. So that's 0.0. We have a ID down here at the table. The source X, source Y, destination X, destination Y, the difference in X pixels and the difference in Y pixels, and the residual pixels. I'll show you what's going on there, but the residual pixels is the important information here. Okay, we have to have 4 points on our map in order to actually place the aerial photograph onto the base map. So I've got one, let's put another one, and this is the button that you need to use in order to select the point, to put a point onto the photograph. This one will delete a point. If I clicked on that, it would delete it. This one allows me to move that point if I want to make it a little more accurate or something. So we're on the left one here. We're replacing a point. I'm going to put a point here. The crosshair seems to disappear every now and then when I do this. click there. And, okay, did I do it right? No, I did not. So I can illustrate how to move a point now. I have this point in the wrong place on this map. So I move over here, and you need to be right on that point in order to actually pick it up and move it. If you click somewhere else and try to move it, if I'm like close to it and try to move it, it won't work. You're really right on it. It's kind of frustrating, but not too bad. So I have 2 points. Let's see, click a new one. Let me show you what I would like to do. If I can zoom in, I'm moving, I clicked on the hand, I'm using the mouse to zoom in. And, whoa! Colors are getting messed up on this image. Well, I'm going to ignore the colors being messed up and show you this. I like telephone poles. If you see here, we have a really nice black line, and it's a little harder to see, but the pole is here, and the black line is a shadow. Here we have a shadow also of a street sign. But if I click at the base where the pole comes in and the shadow comes in, we're right at the ground, and you want to be on the ground in all of the points you pick. If you can't, sometimes you really can't do much beyond that.
I have a question.
Sure, go ahead.
You said you wanted to be on the ground. Does that mean like the corner of a roof won't work?
It doesn't work as well, let's say that, okay. And let me get back over here. I'm going to cancel that one. And the reason is your ground is the lowest point that you can reference. If you have something high, if, like, for example, I selected the top of a telephone pole, that would move relative to the ground depending on my viewpoint. Does that make sense?
You're getting a yes, but she's muted.
Yes,
Okay. Well,
that
I can't
makes
see anybody. I have my.
Yeah, he can't see you because he's on the QGIS screen.
Yeah, on the desktop.
okay. It's muting and unmuting.
Yeah, so I need verbal responses.
I gotcha. I'll watch
Okay.
it for you.
All right.
And I've got a question for you,
Go ahead.
David. So you're saying that because of the roof line, you won't be able to get a good coordinate. So are these maps X, Y, and Z, or only X and Y?
X and Y only.
So
There's no boundary.
So in theory, if you were to pick a roof line or a corner of a roof, it's still considered an X and Y, correct?
You're not thinking properly about this. Let me show you what I think I can illustrate.
If you're picking the corner of a roof, and your photo is from the air, right? And if you have a different angle from the air, you might see a different portion of the ground, right? Because the roof is hiding some of the ground.
Oh, okay, I get it.
Right, got it?
Yeah. Okay.
Here's a better illustration. Can you easily see this shed?
Yes.
Okay. If I picked this corner of the roof right here, it would be in a different spot than if I picked the corner that's on the ground.
Right.
Does that make it?
Yes, yes, yes. Okay, I understand now.
Well, because these aren't straight down. Is that the main problem here?
These are not straight down. That's the problem. Yes. If they were satellite photographs, then we would not have this problem because we would be far enough away that it would essentially be straight down.
So you want to try to select points that are all in the same plane, that are all like at the exact same height in the picture.
That's the right way of saying it, yes.
So what about if you're dealing with a place that has a lot of topographical features?
Yeah, if we have a lot of hills and valleys and things like that.
Yeah.
Well, do the best you can. It won't be a perfect match, and perhaps another transformation besides the one we have selected, projective. Perhaps one of the others might work out a little better because they give a little different distortions. And you probably want to pick a whole lot of points also.
Could you also physically put or get like a GPS type device, kind of like what we were using on that day, and pinpoint different spots in the area and then manually just put those in?
Yes, that's what I was sort of implying a while ago. If, for example, you went to this spot when we were taking the photographs, the aerial photographs, and got the GPS coordinates of it, you could click on that and then enter the GPS coordinates right here.
All right, awesome.
All right, and then you would do OK, and then you would, because we already know what the base layer coordinates are for all the points on it, then it would know where to place that point on the base layer map.
So Scott likes to fly with the GPS data logger. Would something like that be really useful for working on a project like this?
Not really. It wouldn't. You don't get ground points when you fly the GPS receiver.
Okay. Right.
Okay. And this is the same point. Here's a probably better way of seeing what I was talking about. We have the shadow and the light pole coming together right there. So I'm going to pick that spot. And we have OK. So looks like we got the right spot there. We need 4 points in preferably the 4 corners at least on the map, on the aerial photograph, in order to do the projection. We need a minimum of 4, and preferably in the corner.
That's a minimum of 4 points.
Yes.
And
that's
as distributed around the photograph as possible.
All right, I'm just talking over you. Go ahead.
Sorry. A minimum of 4 points and just as distributed around the photograph as possible.
Preferably in the 4 corners. This is just the minimum.
Okay.
I mean, you want them spread out all over the photograph, and the more typically you don't want a whole bunch, but you want a reasonable amount. And
what was that rule? Do you remember? And at the coffee shop, you were talking about the rule of the border, and it would stretch around the border if you did what points? What was the rule you mentioned there?
I'm trying to think of what you're talking about.
Does anybody else remember what I'm talking about? It was like, it was when we were having the conversation of distorting on MapKnitter, and if you worked off the corners versus if you grabbed some with the middle sides.
Oh. I understand what you're talking about now. MapKnitter is a completely different algorithm than what we're using here. Does that help?
Yeah, but I guess I'm just wondering if like the same distortion question is coming in.
It's certainly related to that. Okay.
I think what we were talking about then was that if in MapKnitter you had more points that you could pull for the distortion, you might be able to get a better sort of match. And then this is, you can do as much as you want. So it's sort of going in that direction. Does that make sense?
Right. Yeah. Right. So here you have that luxury sort of to match up more.
Right.
Okay.
Yeah.
Yeah.
It's the same idea but a different process.
Right. Okay.
All right. So okay, I'm gonna pick this point right here as my next point. So I go back over here. By the way, you need to watch to make sure you've got a hand over here. You can move this all around. You can also minimize it. And, this I know is the point that I'm talking about, and I will back up and show you. Back over here, and so I'm going to select this point right there from Map Canvas, and there. That's okay. And I have 4 points at this point. Now, let me show you. Put that up here. This is not an optimum selection of points. You know, you'd want something here, 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 here. I mean, there's some places down here that I could probably easily find. There's like nothing right here that I could use. I could use some of this stuff up here. These are hard to use because they're really not sharp corners. And so it's hard to find something here and here to do. But digressing. If you look at the residuals now, and if you click on the title of the column, it will sort them for you. And we're in scientific notation there. Okay, 369. No, the other way. So this has the largest residual, and the residual is the error that it has used its numerical algorithms to determine how far the pixels are going to have to be distorted. If we start adding some more, let's do that. Let's add some more in here. What do I want to do? Okay, we'll pick something. We'll pick this. So we want to use that point right there. So we'll go over here, and I just happen to know that that's this point right here. So I select point, and select that, that. Let's show you what I wanted to show you here. Let's see. Oh, we have to add another point. Let's see. Let's add a point over here. Okay. Yeah, we'll do the driveway right there.
You're getting a thumbs up from Diana.
Okay.
Replay.
So I select that point right there, and that, and right there, which is on a little off, but that will illustrate what I want to illustrate for you. Actually, I can think about that. I can move the points around. I selected the move point icon, and we're moving point number 5. And if I move it over here, you notice it has a little red tail on it. That's the changes with the residuals here. The smaller the red tail on it, the closer we're going to be able to place the point. And the same thing happens over here. If I move the point, it's hard to not see how the red tail moves all around when I move it. So that's the residuals is what's being shown there. And okay, we're outside of the scientific notation at this point. You'll see 17 is a little high, and that's the largest number in 0.0. Go ahead.
One of the points you have for that 5th point, one is on the bottom of the pathway and one is on the top. Do you see what I'm saying? Sorry, it may be
We're talking about this number 5.
Yeah.
One's north and one's south on the pathway.
Okay. You're saying that I did it in the wrong spot.
Yeah.
Yeah, I did. So we'll move it. And yeah, that's the sort of thing that you need to be careful about. That's what you're talking about, right? So if I go click on the magnifying glass that shows the whole picture, we'll see it's not a great distribution. We don't have anything down here, but we've got 6 points we've picked, and the residual of 15 is the largest, and that's ID number 1, which is this one right here, which makes some sense because that's not a real good single point. If I go look over here and zoom in, and the 1-foot resolution is really not fun. See, we're pretty much off right there. But I'm going to leave it. I'm not going to worry about that. We'll move on. Some of the other icons up here. Let me show you. This one is link the Georeferencer to QGIS. That links this portion to this portion. And this link QGIS to Georeferencer links it back the other way. If you click both of them, then if I have the hand selected over here and I move this, it moves that. And if I have the hand selected over here and I move this, it moves that. So it's convenient sometimes, sometimes it isn't. So, but in order for these to be enabled, one of the things that I have found, you have to have the output raster selected. You have to have this file selected in order for you to be able to select either of the or both of these icons. Okay, so we have enough points. We're going to head and place them on our map. So we go here to the green triangle and we run. And it doesn't take long. And it has placed them. All right, I'm going to minimize that and show you we have an added layer to our map. This is the base layer, and here's the layer we just added. I'm going to zoom back out and show you we have a photograph that has been placed on the map. And if you will see, that looks pretty good. All right, this checkbox over here, if you check on that, you can turn it on and off and sort of see what's going on. The computer's slowed down. But you see where the points are, and come on, computer.
Tough to run a Google Hangout and QGIS at the same time.
There we go. So we have placed a map. So if you continue on with that, you can put several of your aerial photographs on the map. And you'll notice that we can tell there's been significant changes in here over this time period, which is one of the things we would probably be interested in thinking about. And essentially, that's how you go about placing these. Is there any questions? I can show you. I've done this whole process. I can close this one out and open up the one that I've already done.
Dan, would you share your demo files so we could play along with this folder in our QGIS?
I have no problem doing that, but they're rather large. So we need to figure out where to put them. So I guess we could figure that out on email afterwards.
Stevie, will they fit on the Google Drive? You're muted.
I'm not sure that they would fit in the one that we've been using for our photos. We've put a lot of stuff on it already, and I've gotten an email about it. But I think we can maybe share access on Dropbox. What do you think, Matthew?
Yeah, we can make a public link from our Dropbox. It's like a public folder we can put it in, and then we'll have a web link we can share, I think. Awesome. That'll work.
Do you want to make one, Matthew, and send out the link?
Sure. If I have the, where are the files though?
Do you want to make the Dropbox in a place where Dan could drop them? Does that work?
Perhaps we can handle this.
We'll do this but later. Yeah.
Okay.
Other questions?
Sorry.
All right. Just to illustrate how big the files are, this is over 59 megs is the base image, and the one we just did was either 42 megs or 58 megs. Those are two of the TIFF files that I've generated. The JPEG files are smaller, as you can see over here. So quite a bit of files. So if there's no questions about this,
I think Dan disappeared.
Dan? Oh, you're back now.
I don't need to say. All right. Okay. The question is, do you want me to move on to what I've already done previously, or do we need to talk about this anymore? I guess we don't need to talk about this anymore. Okay. The other thing is, I still had this open, but we have placed it already, so all you really need to do next to get the next picture is you just repeat the process, open the raster, take the defaults most of the time. Everything should more or less stay the same, the options that you've already selected. So if you close this, and oh yes, I forgot about this. Save GCP points. These are these points that are numbered with the yellow boxes. They will be saved into a file. I suggest you save them because you can iterate back over this. You can go to another image and come back to this one, and you'll have the points are saved, and you can say, oh, I just need to move this point a little bit rather than having to do all your points over again. So I highly recommend that you save the ground control points. That's what they're called. Any questions? Okay. I will close this. I'll open my reset. Yeah, I'm going to save. Don't need to. I'm not going to save it. All right.
Dan, you're choppy on us again. You might need to close a couple things or give it a minute. We can't hear you.
Okay.
Oh, that's a little bit better.
Okay. I really don't have much open that I can close.
Nope, sounds good now.
All right. So I have 8 aerial photographs that I've added to the base image. And you can group the images. We took 2 sets of aerial photographs, one from the north and one from the south. So it was logical to group them that way. And I can turn off separately or together, and turn them off together. It's kind of nice. And there we have a map. All right. Any questions? I think that's about all I have.
I have just a couple of comments based, kind of going back to the discussion with the projections. As far as, I think Dan hit the nail on the head. As far as picking points on roofs and stuff like that, you typically do want to pick points on the ground. And if you have an area that has terrain, if it's not a flat area, then you would want to definitely use something other than the projective projection. The projective projection is really good if if it's a plane on a plane, and the sensor in the camera is a plane, and this is a very flat area. So as long as you're staying on the flat area, the projective projection is going to work really well. And one way to demonstrate the projective projection is just getting a projector and kind of moving it on a screen. You can kind of see how it changes shapes. It always has straight lines on the edges, so it doesn't really warp it. It just kind of projects it differently. So if you had if you were working in an area that had some terrain, you'd want to use one of the polynomials, probably the 2nd or 3rd degree, or maybe even 4th degree polynomial. And it's the same basic process. You just select a different processing or another algorithm basically to do the stretching. And with the higher you go in the degrees of polynomial, the more points you need. So if you're working in an area that has some hills or mountains, you just need to pick a lot more points.
And the higher the polynomial, the more points you need.
Right, the higher the polynomial, the more points you need, and basically what it's going to do is do some more intensive warping. And as you get into the higher, a third order polynomial, you would definitely want to have your points distributed all around the area. Otherwise, the fit is going to be really good where you have your control points, but the fit's going to be awful where you don't have control points. With the projective projection, it's not as much of an issue because it's basically just going to look at the points, then do this very simple projective projection. And one thing, I don't know if people noticed it, but when you were looking at the residuals, when you only had 4 points, the residuals were effectively 0. It was 10 to the minus 7th or 8th or something like that. It was when you added that 5th point that you actually got residuals. And the reason is that it's using, it needs to have at least 4 points to make that projective calculation. It's just like if you're doing a regression with a line, if you have 2 points, the R-squared is going to be 1. With the projected projection, with 4 points, the residuals are going to be 0. But as soon as you add a 5th point, then all of a sudden the residuals jumped up to, 10 meters or something like that. But I actually learned some things about QGIS doing this, doing the mapping stuff like this. It was nice to see. Thank you.
And here I have a aerial photograph that shows the distortion. That it's not a rectangle. You can see the camera was probably over here and pointing in this area. That's why you get the distortion. It's a keystone is the description of that shape. Anybody else?
Dan, I think you covered this just before I got here, but where did you get the aerial imagery from?
Oh, you're talking about the base layer?
The base layer.
You're talking about this, the 1-foot resolution images.
Right, that one. Where did that come from?
It came from MARIS, M-A-R-I-S. If you'll Google that, you'll find it's the Mississippi GIS repository.
Okay. Do you know if there's a similar one for Louisiana?
I strongly suspect that there is.
And this is a GeoTIFF, right, Dan?
I didn't hear you.
Is this a GeoTIFF file that's the base layer? Is that what you're using?
Actually, it is not. It's a DEM, I think.
Oh.
No, it's not. No, it's not a DEM. Let me look it up. Okay, the clipped one is a GeoTIFF, yes, but that's not what I downloaded that took 12 hours to download. And it's a SID. There we go. This is the file. As you will see, it's 5.7 gigabytes. Anybody else?
I was just gonna look and see if I can get those files from the National Map Viewer. Does anyone know if that's true? If I can get them from the USGS?
I don't know if Mississippi has placed them there, but I mean that's a good place to look for this sort of information.
The USGS might have different aerial photos. I don't know if they necessarily have the same ones. NOAA might have some. I know NOAA has a lot of LiDAR of coastal areas, especially, and that's NOAA Digital Coast. If you want to look for that.
We put together a wiki a little while ago of open source aerial imagery as well. So if anybody knows of others, add them on to there. I'll try to find the link. Also, I'm on here twice, which is way too many times now.
Yeah, I'm wondering if we can update that list to include like files that will load in as a base layer like that. Does anyone know if a GeoTIFF would work just as a base layer? Because that's I'm wondering in this specific case where we get those base layer images.
I'm using a GeoTIFF as a base layer. And how do I turn off my screen? Oh, okay, my screen share is turned off now.
Okay, yeah, I found it. The wiki is aerial images in the public domain. If I can, I'll copy it right here. If anybody knows of others, there it is. Does anybody else have other comments or questions, ideas?
Okay. I don't see any on the chat.
There were two people on the chat. One was talking about dust monitoring. The other one, he just joined the chat room again now and mentioned that he would be joining the call, but I'm not sure. So I think he's watching. So if you have any questions, post them in and we'll funnel them over. So I guess I have one thought I was sort of throwing around is what is the situation where you would find it preferable to use QGIS over MapKnitter? So I guess I have one thought I was. Uh-oh. So Fernando would find it preferable to if you can mute the one that's on the website over MapKnitter because it's feeding in twice. Uh-oh. So, Fernando? Okay, I'm going to mute you. Okay, if you fix that, unmute. So, Dan, do you have any thoughts on that?
All right, what was the question?
When, like, just from your experience using all these different interfaces, when would you find it preferable to use QGIS over something like MapKnitter?
Well, I like the GIS platform, and that you can have layers that you can turn on and off. There's all sorts of flexibility that you have with a GIS platform that you don't have with MapKnitter. But it doesn't appear on the web as a map. If I'm just using a GIS platform, I have to move it from that, such as QGIS, to some other web server in order to publicly display it.
Got it.
Those are the main trade-offs here. We can take this map that I've generated and place it on the MapKnitter website. I do believe. I have not tried that yet. But, so today I was just mainly showing how we could go through this process that I've demonstrated.
Okay. Thanks.
But just one other comment related to the MapKnitter thing. It's another option instead of uploading your own imagery is to use like Google Earth or Bing Maps as a background. You can do that in QGIS. There's a plugin called Open Layers, and that way you don't.
Yes. Let me talk to you about that. I tried that, Google Maps, and I had all sorts of problems doing that, and I therefore ended up using the maps that I got from Maris. When I placed a point on the Google map and then wanted to move the map around so that I could place a second point, and then the point did not stay where I placed it. And I was thinking that that was just a projection issue, and so I had to go off and figure out what Google Map was using as their projection. And I entered that, and so I had it all set up like I think it should have been, and I still had the problem. So I was not successful using Google Maps as a base layer. And that's the only one of the possible public map layers that I could have tried, but that's the only one that I did try.
Yeah, I usually use Bing
Perhaps
Maps, and it seems to work all right. Sorry.
Go for it, Ned.
I often use the Bing map. I mean, I don't actually use the Google layer very much, and the Bing map seems to. I mean, I've had decent luck with it, so I'm not sure why it wasn't working.
Okay, well, I did not try Bing Maps. I just tried Google Maps. Do you know what the Bing Map projection is?
The native projection is probably WGS 84. I think it's the same as Google. But if you have that project on the fly, that should, as long as you have the background set, it should be okay.
Can you explain what the projection on the fly really does?
Actually, what you said was correct. It reprojects the data that you're bringing into the project, whatever you said is the project projection. There's a couple issues with Raster. It doesn't do a perfect job because it's doing a lot of interpolating when it does the projection. With vector layers, it's going to do pretty much an exact projection. And one word of caution: when you are doing project on the fly, you might be working with two layers that are in different projections, but not be aware of it. And so you might think, so for example, if you're working in a UTM projection, that's your project coordinate system, you might bring in something that's WGS 84 and overlay it, and it'll overlay on the UTM just perfectly. And then, at least with me, I mentally start thinking that that other layer is UTM as well. And that's caused some problems. So oftentimes I'll actually turn it off just so I can make sure to see if those layers are in the same projection and overlaying properly, or if it's just being projected on the fly.
Yeah, that's a real good point that you really need to be aware of, that all of your layers need to be in the same projection or they won't line up properly. And I think Google's projection is not a standard projection. It's some weird modification of it. In my memory, I don't remember exactly what it is at this point. Any other questions?
Dan, this is David. Is it possible to use shape files?
Oh, yes.
SHP files?
Yes. Yeah, there's all sorts of annotations and all sorts of things like that. Oh, yes. That's easy to do.
I gotta find the websites because there was a lot of free ones out there.
Well, free ones? What do you mean?
Like free shape files of the entire United States, of all the rivers, of everything.
Yeah. The Maris site, for example, has all of those things, the streets. And, OpenStreetMaps, too, have a lot of those things. Yeah. But, you can also, draw things on there yourself. You can do polygons, lines, points, color them, put symbols on the map, and then you can do calculations. You can say, is this within certain feet of that? Is this, you can do an addition and subtractions and differences of areas, and all sorts of things are doable with GIS.
As for the, hi there guys. There's also Tiger shapefiles. That's a good resource. It's shapefiles by the U.S. Census Bureau. So I'm going to paste the link here.
Yeah, there's lots and lots of sources for GIS data. I think there's a single U.S. government website that you can go to and get all of the links, at least, to all of the other government data stuff. National Weather Service, you can use, they provide GIS data also.
Any other thoughts here?
I really need to take a biology break, so I think I'm done.
Okay. Thanks for sharing everything, Dan. That was really awesome.
Yeah, thanks, Dan.
Well, thanks for listening. Being a good audience. And asking questions.
Alrighty, and we've recorded it forever. It's going to be on the OpenHour page.
Awesome. And the links, are they also going to be part of it also, Stevie?
Yeah, I'll save the links and post them with the call.
Great. Thank you.
Sure. So if you have others, actually put them on here and I'll add it.
All right.
And we can add it to the web page.
You can. You can edit. You can even edit the OpenHour page.
Trying to say. All right. Goodbye.
Goodbye.
Bye. Thanks.
Thank you, Dan.
Bye.